Okay, square roots and the Pythagorean theorem. Okay, so we're going to find the square root of a perfect square, approximate square roots using a calculator, okay, and use the Pythagorean theorem to solve application problems. Okay, let's take a look here. Notice here what square roots are. Okay, we have a table of whole numbers from 1 to 20. Okay, what this is, remember what squared means, that just means 1 times 1. So these right here, okay, when you hear the word perfect square, these are the perfect squares right here. Okay, 1 times 1 is 1. Okay, 2 times 2 is 4. So 4 is a perfect square. Okay, 3 times 2 is 9, and so on and so forth. These are all perfect squares on this side. And notice you can keep going. You can go 21, 22, 23. So there's an infinite amount of perfect squares. Okay, so let's continue on. Okay, the symbol here is called the radical sign. Okay, the number under the radical sign is called the radicand. Basically, you're going to see numbers in here. Notice right here. The complete expression, such as the square root of 49, is called the radical or radical expression. Okay. So notice here, what's happening is this. When you take the square root of something, you're going back to its original number. So let me kind of give you an example here of what they're showing. Okay, let's look at 7. Remember, when you think back, you saw 7 squared equal 49. Well, notice if I take the square root of 49, then I get back to the original 7. Okay, this is not the 7 squared, because to create this 49, you had to have 7 times 7. Okay, well, this takes us back to the original 7. And these are always really pretty numbers when you think of perfect squares. Okay, only perfect squares, because notice that's all they're giving us. With this one right here, the square root of 4 is 2, the square root of 9. These are all perfect squares. It doesn't mean that you can't have some ugly number in there. That's not what it's saying. You can have different types of numbers, and you'll see that shortly. So let's evaluate some here. Use your memory of the tables. Okay, well, let's think what's 15 times 15. If you think back, 15 times 15, if you can't remember, 15 times 15 is going to be 225. Okay, let me write that down. So 15 times 15 is 225. Well, how about 11 times 11? 11 times 11 is going to be 121. Because remember, whenever you have a square, okay, 11 squared is the same as 11 times 11. Okay, that's exactly what you're seeing there. Let's do some more here. Okay, once again, now look. Think back. What two numbers that are the same can I multiply together to get 256? Okay, and if you think about this, what two numbers? Okay, let's come in here. Well, if you think about it, 16 times 16 equals, well, that equals 16 squared. Well, that equals 256. And this is saying, what's the square root of 256? Well, the square root of 256 is 16. It gets me back to the number that I needed to multiply by to get to 256. This one should be a little bit easier. It's a smaller number. What times what equals 81? Well, notice again, this is going to be 9 times 9. Well, 9 times 9 is the same thing as saying 9 squared. 9 squared is 81. I can take the square root of 81, and what number do I need to multiply by, okay, by itself to get to 81? Well, 9. And that's exactly what it's trying to show us here. Let's continue on here. Okay, notice these, okay, we're going to use a calculator. Okay, and because there's no number that you can just think of in your head to just come up with the square root of 2. Okay, you're going to learn later on these are called irrational numbers. So whenever we take the square root of 2, we get a really, really ugly number. And notice this thing says approximate it to the 10,000ths place. So looking at the square root of 2, we can say, well, A here, that's going to be the square root of 2. Well, what number do I need to multiply by to get the square root of 2? Well, you end up having to get 1.4142. Well, there's tens, hundreds, thousands, 10,000ths. The next number would be a 1. So this is as far as we need to go on this one. But this number keeps going. Okay. Notice that's why you could never just really figure one of these out. So let's just do B real fast, just so we can kind of finish it off. Square root of 18. Okay, this one, the square root of 18, okay, is going to be 4.2426. Okay, the next number after it's a 4, so we can just round down. So that is the estimated. Once again, this one is just going to kind of just keep going. It's going to, there's no rhyme, there's no reason, there's no sort of pattern to it. Okay, let's continue on here. All right, right triangle, a right triangle containing a right 90 degree. Here we are. Okay, hypotenuse here. Hypotenuse is always the longest side, and then we got legs. Okay, these right here, you're going to see, you can label these A, B, B, A, B here, doesn't really matter. Okay, you'll see that in the next slide. But the longest side of a right triangle is always going to be called its hypotenuse. Always. Okay, there's no other fancy way to think of that. It's always going to be that. So, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. That's a whole bunch of mumbo jumbo. Look at the formula. This is all it is saying. If I give you a number here and a number here, when I square them, when I multiply them together, I'm going to get this number here. I can take the square root of this guy and come back. So let's do an example here. Okay. Show that the triangle with the sides of lengths 3 inches, 4 inches, and 5 inches must be a right triangle. Okay? Must be. Okay? So we have a triangle here. We kind of draw this out. I think they already gave me one here. Hold on. Yes. Oh, no, they didn't. I'll have to draw this one out. Okay, so let's draw this out. We're going to show that this is a right triangle. So I have a right triangle here. Notice I'm not going to be able to draw this perfectly, but I know it's right because I'm going to draw my little square there. So they're saying that it has side lengths of 3 and 4. 5 is my longest side. I know that's going to have to be the 5 here. But they're saying 3, probably 3. Let me move that around because obviously the 4 is going to be the longer one. Okay. What they're saying is, how do I know this is a right triangle? Well, let's put this in the formula. And remember, you can write that C on either side here. But notice how they wrote it here. 5 squared equals 3 squared plus 4 squared. Well, what's 5 squared? 5 times 5 is 25. Well, 3 squared is 9. 4 squared is 16. And look at the math. 16 plus 9 is going to give me 25. So yes, I do have a right triangle. It does work. Now, if for some reason, if they ask you this question, they go, hey, what about 4, 6, and 10? Well, you just plug it all in. If the math does not work, then it doesn't work. Don't force a square peg into a round hole. Okay, let's do a little example here. Okay, find the length of the hypotenuse of a right triangle, okay, with legs 12 centimeters and 5 centimeters. So we don't know this yet, okay, but we do have the formula. Let's pull up the formula here. We do have C squared equals A squared plus B squared. And you'll also see this written as A squared plus B squared equals C squared. Well, let's make this my A and this my B. Doesn't really matter, but once you label them, stick with it, okay? Plug everything into the formula. Okay, well, I've got 5 squared plus, now I've got a 12. It's squared, and then it's all going to equal C squared. Well, 5 squared is going to be 25. Okay, 12 squared, okay, you can do it on your calculator, just know it, it's going to be 144. Well, whenever I add 25 plus 144, okay, I get 169. Well, that doesn't look right. Well, notice what I need to do now is now I'm going to take the square root of this number right here. When I take the square root of 169, well, take the square root of 169, though it should be one that you can kind of start learning, okay, I end up getting 13. So right here, this is 13. So I have a triangle with 5 centimeters, 12 centimeters, and 13 centimeters. And that's how the Pythagorean theorem works. Okay, you can find that unknown side. And as we get up through things later on, you're going to find out that you could be missing a side A or side B, and then you'll be able to kind of calculate and find those things as well.